Okay, so we are going to do the last section of chapter 11, and this is going to be on polar functions. And so let's do a little bit of a review. What are polar coordinates versus our rectangular coordinate system? Well, just remember, rectangular has to do with an x and a y-axis. When we work with a polar coordinate system, we work with an angle theta as well as r for our radius. Okay, we have in polar coordinates, just a reminder, the origin O, we call that the pole, and the positive x-axis as the initial ray. And again, we use the trigonometry to express the angle measure. Okay, so let's take a look at what that means. In terms of an example here, we see this is the ordered pair 2, 2. Right? The corresponding polar coordinates, right? If you think about the angle, right? Imagine if we look at that segment, what would that angle measure be over here? That would be pi over 4, right? Because if you think about tangent of theta would be 2 over 2. So where's tangent equal to 1? At pi over 4. And how do we get the length of this segment? Well, just think if this is 2 and this is 2, right? We can do a quick Pythagorean theorem, and that's how we get to root 2. Okay, so when we're graphing in polar equations, or polar coordinates, excuse me, we're always going to start by locating the angle. All right, so we're going to draw the angle first. Obviously, right, that's our initial side. And 3 pi over 4, well, that will go right in between 2 pi over 3 and 5 pi over 6. So here is my angle, 3 pi over 4, and that's in the positive direction, so I want to draw the angle denoting that. And then I want to count. So you see this like first circle, that's a radius of 1, and we want to count 3 because r is 3. So 1, 2, 3, and we're just going to put a point there. Okay, so start with the angle, all right, and then plot the point. Okay, this one has a negative pi over 3. So negative pi over 3 is the same thing as 5 pi over 3, and we want to go this direction. And now this one has a little bit different approach because there's a negative in front of the r. That means we're going to take this line segment and we're actually going to extend it in the opposite direction. And now on this side of the line, we're going to count 1, 2 units, and that's how we'll plot that coordinate. Okay, rectangular and polar conversion. So to convert from polar to regular, that's going to be x equals r cosine theta, y equals r sine theta. When we go the other direction, rectangular to polar, right, this should look familiar, Pythagorean theorem. So r squared equals x squared plus y squared. And we know tangent is the ratio of y over x. Okay, so let's start off with polar coordinates and finding rectangular coordinates. Okay, and we also want to graph it. So we can graph it first, it doesn't really matter. We'll start off with 5 pi over 6, right? So here, and then notice, so here's our angle, but there's a negative 2, so that means it's going to go the opposite direction, and we want to count 1, 2 units. So that's the ordered pair. Now let's find the coordinates. So we have x equals, so it's, again, it's r cosine theta. So negative 2 times cosine of 5 pi over 6. So that's going to be negative 2. So cosine of 5 pi over 6, that's going to be negative root 3 over 2. So we get positive root 3. And then for our y coordinate, that's going to be r sine theta. So we will have negative 2, and sine of 5 pi over 6 is a half. So we get negative 1. So our ordered pair is 3, -1. It's also helpful to look, does this point right here, does that look like 3 negative, or root 3 common -1? Yes, and we can also confirm we're in the correct quadrant, we're in quadrant 4. Okay, another one. So let's start 2 pi over 3. So here's our angle. And now 2 root 3, if you think about 2 root 3, what would that be approximately? So root 3 is about, so if you want, you can like do this on your calculator to get an approximation. Root 3 is about 1.73. We'll say 1.7. So 1.7 times 2 is going to be about 3.4. So we'll go right between 3 and 4. So we'll count 1, 2, 3.5, right about there. Doesn't have to be perfect. So we'll have x equals 2 root 3 times cosine 2 pi over 3. So 2 pi over 3, that cosine would be a negative 1/2 there. So we'll get negative root 3. And then for y, right, 2 root 3 times sine 2 pi over 3. So 2 root 3 times root 3 over 2, and that gives us 3. So our ordered pair is negative root 3, comma 3. Okay, now let's look at the opposite. So let's look at how we're going to change from rectangular, and we're going to rewrite it so that it has the angle in terms of, the coordinates in terms of polar. So if we have r comma theta, right, just a quick reminder, we can find multiple coordinates that have the same location, but we're either adding or subtracting a multiple of 2 pi. You can also change the r to be negative, and then you can just add or subtract a multiple of pi. Okay, so let's plot the point first. So -1, -1. Now, if you forget the formulas, you can also just think about, think about this here. Think about my angle. What's my angle going to be here, right? We know tangent of theta is going to be -1 over -1. So where is tangent equal to 1? Well, that's equal to theta when theta equals pi over 4 and 3 pi over 4, but make sure we're looking at the quadrant we're located in. I said pi over 4 and 5 pi over 4, not 3 pi. So theta has to be 5 pi over 4. And then we also need to find, we have x squared plus y squared equals r squared. So we have 1 squared plus 1 squared equals r squared. So r is the square root of 2. So we want to find 2 sets of corresponding polar coordinates. So I'll use the first one. It's just r root 2 and 5 pi over 4. Now, if I want to find a second set, we can either keep r positive and add or subtract 2 pi, or I can change the root 2 to be negative, and I could subtract or add a multiple of pi. I'll subtract pi, and that'll just give me pi over 4. Okay, next one, we have negative root 3 comma -1, also in quadrant 4. Again, root 3 is about negative 1.7, so we'll go over to the left 1.7, down 1, right? So that's what we're looking for. Our tangent of theta is equal to -1 over negative root 3. The only combination that would give us that would be a -1/2 over a negative root 3 over 2. So think 1 is sine equal to -1/2, and 1 is cosine equal to negative root 3 over 2. This is going to be when theta is 7 pi over 6. Okay, and then for r, we have negative root 3 squared plus -1 squared equals r squared. It's going to give us 3 plus 1, so r is going to be 2. So we'll have 2 comma 7 pi over 6. And we can do the same thing. We can do, well, actually, maybe we'll do this one different. So 2 comma, if we were to add 7 pi over 6 plus 2 pi, so 7 plus 12 gives us 19 pi over 6. Or we could do something similar that we did in the last problem. All right, moving along. Graph the set of points whose polar coordinates satisfy the given condition. R equals 3. Well, recall our x squared plus y squared equals r squared. So x squared plus y squared equals 3 squared. Well, what's this? This is just the equation of a circle. The center is at 0, 0, and our radius is 3. So we'll just plot our 4 points and make a circle. Try to get through the points, but that's okay. All right, next we have theta is pi over 3. Well, remember, tangent of theta is equal to y over x. So tangent of pi over 3 equals y over x. Well, tangent of pi over 3 is root 3. So that means y is equal to root 3 times x. So just keep in mind, we'll have y-intercept at 0. And then, again, root 3 is about 1.7. So we'll go up 1.7 and we'll draw our line. Okay, changing polar equation to rectangular form, and then we want to graph it. Okay, so again, let's remember x squared plus y squared equals r squared, and y equals r sine theta. Okay, so just keep those in mind when we're trying to manipulate this to change it into that rectangular form. So we want to get it all in terms of just x and y. Okay, so if I start off with r equals 4 sine theta, if I multiply both sides by r, notice what I can replace, right? Y was equal to r sine theta. And on the left side, we get an r squared, which is going to help us because 4 r sine theta, okay, so r squared can be replaced with, right, I can replace it with that. So I'm going to have x squared plus y squared equals 4, and I'm going to replace the r sine theta with y. Okay, I'm going to move the 4y to the other side. And now we're going to bring back something that you probably learned so long ago, but we're going to complete the square because we want to be able to graph this. So I have x squared plus y squared minus 4y. So just with the y's, remember, take half of b and square it. So half of 4 and square it will give us plus 4. But of course, whatever we do to one side of the equation, we have to do to the other to balance it. So we have x squared plus y minus 2 squared equals 4. So what do we have here? It's a circle. Okay, so here's we got the equation. So let's just remind ourselves, what's the circle have? Has a center at 0, 2, and the radius equals 2. Right, so just keep in mind this x minus h squared plus y minus k squared equals r squared is always going to have a center h, k, and radius equal to r. So kind of just, it's been a while, but we need to at least know that part. Okay, so let's plot the center, 0, 2. And we have the radius is 2, so I'll just go around and graph it. Okay, so let's take a look at parametric equations for polar curves. Okay, so if r is equal to f of theta, then the curve is defined, right? X equals r cosine theta, so that would be f of theta times cosine theta, and y is r sine theta, so we would take f of theta times sine. Slope of polar curves should look familiar, dy dx. We're going to do dy d theta over dx d theta. Okay, find the slope of the rose curve r equals 2 sine 3 theta at the point where theta equals pi over 6 and use it to find the equation in the tangent line. Okay, so first thing we want to do is we want to redefine parametrically. Okay, so again, here's r, and we have our theta. Right, so again, what do we want to do? Right, we want to take r times cosine theta. So for x, we get 2 sine 3 theta times cosine theta. And then for y, we get 2 sine 3 theta times sine of theta. Now, I want to do, remember, we're going to find the slope, so we want to find dy dx, so we have to find dy d theta and dx d theta. So I'll just do that right here because we have to do a product rule and we have to do a chain rule. So let's see here, dx dt is going to be what? We're going to get, right? So let's do the derivative of 2 sine 3 theta, so that'll be 6 cosine 3 theta times cosine theta plus, now I'll leave 2 sine 3 theta times the derivative of sine theta would be, or sorry, cosine theta would be negative sine. So I'll just change this into a minus sign here. Okay. Oh, I just realized I put a dt. I'm getting mixed up with my variables. This should be a d theta. Okay, so dy d theta. So this is going to be 6 cosine 3 theta times sine theta. And then plus 2 sine 3 theta times cosine theta, right? Derivative of sine. Okay, so let's do dx d theta, evaluated when pi, or theta equals pi over 6. So, well, that's easy because when I plug, right, I'd have cosine 3 times pi over 6 would be pi over 2. But we know this is all just going to become 0. And this is going to become, so it's going to be 0 minus 2. Sine of pi over 2 is 1. And sine of pi over 6 is a half. So I just get negative 1. And then for dy d theta, evaluated at pi over 6, right? We're going to get 0 again, but let me just write it out. So it'll be 6 cosine of pi over 2 sine of pi over 6 plus 2 sine pi over 2 cosine pi over 6. So we'll get 0 plus 2 times 1, and then cosine of pi over 6 is root 3 over 2, so we just get root 3. Okay, so that means dy dx is going to be negative root 3, right? dy d theta over dx d theta. So what's my tangent line? It's going to be y minus. So think about what's x going to be at pi over 6. X is going to be, so just x is going to be root 3. And y is going to be 1. So I have y minus 1 equals negative root 3, x minus root 3. There's my tangent line. Okay, so that's where we will leave it for now. In the next lesson, we will work with area.